Hello and welcome in to my channel. I'm Professor O and I am doing this live stream for math tutoring. So if you have a math question or a problem you would like to see work done, you can post in the chat. And in the meantime, I'm going to be up here working a problem. Just in case I get students. That's the main reason why I'm doing this. So yeah, I was hoping to have a live interactive where people can come and hang out and do math together. So that's what this channel's about. In the meantime, I am going to be practicing working on my board and sketching well, hopefully, I'm not sketching a picture tonight, but I'm going to be writing all over my board, doing some math. So I am right now working on systems of linear equations, and I'm going to be solving one pretty straight through using matrices. So I'm going to use the same technique that I did last week, except for I just want to go through it one more time and see if I can do it pretty smooth. So happy Monday. I hope everyone's doing well. And yeah, go ahead and get started. So this one, we found the solution on Friday. I feel like I want a little bit more practice before I move on. So we'll just do one more. Hopefully it works out clean and we'll see how it goes. Let me get this erased. So there's other methods of solving using matrices. There is something that's called an augmented matrix, where there you attach your coefficient matrix to, it's called a, oh, I just lost it. It's the identity, sorry. I was thinking inverse. It's not the inverse, it's an identity matrix, and you pair them. So I'm thinking about maybe trying one of those next. Those are a little bit more challenging. So this one is more like a method that it's going to work no matter what if you do the method correctly. The other one is more of a unique process and creative problem solving. So all right, so I have this worked out, and I know that this has a solution in the back because I looked it up. Make sure. Yeah. 12A. Okay, it's in here. All right, so this one I picked out because it's fractions. So this is going to be 3/2 x plus 3z equal 15. And I don't know how I picked up that marker. I'll try this one. Then we have negative x plus 7y minus 9z, and that equals negative 45. And then I have 2x plus 5z, and that is equal 22. Make sure I wrote it down correctly. 3/2 x, 3z, 15, negative x plus 7y minus 9z equal negative 45, and then 2x plus 5z, and then equal 22. Right, and I have not done any work on this problem. And I just wanted to have a fresh problem to see if I could just work through this method. Pretty straightforward. In a timely manner. All right. So 12a, we've got 6, -3, and 2 for the solution. 6, -3, and 2. Okay. So we are going to put that solution right up here. Six, -3. What did I say? 9? Let's see what I said. Or 7. 6, -3, and 2. Like that. I was way off, wasn't I? It's an even number. And 2. All right. So I did one of these last week, and I just felt like it was a little rough. Took me 2 days. I had to redeem myself on Friday because I worked it on Thursday and I did something wrong. Friday we came back and worked it clean, and so now I just want a fresh problem. See how we do. So what I'm going to do is I'm going to first split my my equations up into matrices, and I'm going to make a it's called a matrix of coefficients, and we're just using the coefficients of my variables. So we'll have 3 different matrices. We'll have a 3 by 3, and I'm going to try to write smaller. So this is just me practicing writing on my board. One day I want to be really good at it. So we got 3 halves, 0. We're just using a placeholder because there's no y, and it all has to line up perfectly. So the second column must be all y's. So since there's not a y in this first equation, I'm just going to put 0 in for a placeholder. It's kind of important. And then we have -1. Looking at just the coefficients, 7, -9. And we have 2, 5. We don't have a y here, so we're going to do that again. We're going to put a placeholder in here for 0. And it's 5z. And I've listed successfully all of my coefficients, making sure column 1 is x, column 2 is y, and column 3 is z. So I'm going to multiply that by a 3 by 1, and I'm going to list my variables here. So I have x, y, and z. And then I'm going to set that equal to a matrix of my constants, which are these 3 numbers here. So a constant is just a number value without a variable attached to it. And coefficients are, it's a number value in front of the variable. It's being multiplied. It's multiplying the variable by a factor. Okay. So once I have this, I'm going to take my matrix of coefficients, and I'm going to first calculate my determinant. And the determinant is practiced like this. So you're going to write all of your matrix out, and then you're going to have an additional 2 columns. So we'll just do it here to kind of stay, we're going to try to see how organized I can be with this as well. So we've got 3 halves. Go ahead and write another one in here. -1, 2, 0, 7, 0. And we've got, hang on, 3, -9, and 5. And I'm going to draw my matrix bar, and then I'm going to repeat these 2 columns here. So 3 halves. So this is the determinant. I didn't leave room, did I? Here, we'll try to sneak it in here. Determinant. Okay. 3, -1, and 2, and 0, 7, 0. I'm calculating this determinant first because if you calculate your determinant and you get 0 for your determinant, then you can't use this method to solve it. It doesn't mean there's no solution necessarily. There may be a solution, it just doesn't have an inverse. So there's other methods of solving the system, you just can't use this one. So we'll first calculate. We also need the determinant per the formula for calculating solving this way. So we might as well do it first. So we calculate determinant by first taking this. We're going to take this diagonal. So it's 3/2 times 7 times 5. So we'll put it here, 3/2 times 7 times 5 plus this diagonal. It's going to be 0 because 0 times anything is 0, but we'll go ahead and, just for the method, we'll go ahead and practice 0 times -9 times 2. And then we're going to use this column now. And we're plussing all of the forward slashes. So 3 -1 times 0. Okay, now we're going to go the other direction. So we're going to do this diagonal first. Well, now with the backslashes, we have to subtract. So we're going to put that minus there. We can put one big parentheses if we want. And we have 2 times 7 times 3. Minus the next diagonal, which would be this one. So it's going to be 3/2 times 9 times 0, or -9 rather. 3/2 times -9, we'll just put a parentheses, times 0. And then we have one more diagonal, it's this one here, 0 times -1 times 5. All right, so we have to evaluate this. 7 times 5 is 35. Let me get my calculator, we can do this a little bit faster. So this is giving me 105 divided by 2. And then this is 0. This is also 0. Look, I didn't use parentheses. Let's stay consistent. Plus 0 minus 2 times 7 times 3. So that's 6 times 7. That's 42. And then I have 0 and 0. Minus 0, minus 0. So if I want to put this in a fraction form, this is going to be 105 divided by 2. So 42 times 2 is 84. So I can say that this equals 105 divided by 2 minus 84 divided by 2. So 105 minus 84. Is that 21? Okay, it's 21. So we have to determine 21 divided by 2. And it is not a pretty number, but if I calculated everything correctly, it's correct. So that's what matters. So determinant 21 over 2. So we'll circle that. I tried to pick a problem with fractions just because it's good practice. All right, so the next thing we're going to do per this method is we have to calculate, it's called the matrix of minors. And I think that this is probably the hardest part of this, this entire method. So we'll practice it and we'll just have to be real careful. Okay. So recall we have X, Y, Z. And that's going to equal my A, B, C, D inverse times my coefficients. Or, sorry, it's not time coefficients. It's the inverse times, yeah, so it's, how do I list the constants? I'm going to say 15, negative 45, and 22. Okay, see, I can already tell I need to practice. So the minors. So we're going to have a big matrix for this one, because this one is a matrix of matrices. And I have a really good marker in here, and I don't know what happened to it. I'm going to have to go ahead and erase this size because I'm not sure. All right, we've got to draw 9 of these little matrices in here. We got 1, 2, 3. I can already tell that's not organized. And what we have to do is we're going to build these matrices of this matrix of minors. I'm trying to get the lingo correctly. It's a matrix of minor matrices. Well, once we do this, we're going to have to get the determinants. So what we're doing is we're taking and we're crossing out the rows and columns of the particular position. So recall that this is row 1, column 1. So I'm going over here to my coefficient matrix and I'm crossing out the rows and columns and looking at this resulting matrix of 7, negative 9, 0, and 5. Okay. So 7, negative 9, 0, 5. And this one is negative 1, negative 9, 2, and 5. And this one is going to be negative 1, 7, 2, and 0. This row, this position, is going to be 0, 0, 3, 5. No, wrong place. 5, and then the middle one is just the corners. These 4 corners. So we've got, is it 3 halves? 3, 2, and 5. This one is going to be these 4. So we've got 3 halves, 0, 2, 0. And then this one going to be these four: 0, 3, 7, negative 9. Do it again. 0, 3, 7, negative 9. And then this one, will be these four. So 3 halves, negative 1. Three and negative 9. And then this one, it's the last one. So it's these two, these four. So 3 halves, 0. Negative 1 and 7. Perfect. I hope I did okay. I am going to go back and just really quickly make sure that they all look different. None of them look the same. That's usually a check in place. All right, I think that we have successfully done this. So what I'm going to do is I'm just going to erase a little bit of this, just what I need here. And I'm going to have to, so we've got the determinant 21. So we're going to need a little bit of room here. So we can, what we're doing is we're going to calculate the determinants of all of these. And it's going to produce a new matrix. So we're going to go ahead and write that matrix out here. I can put it right here. Scratch that. We'll put it over here. Okay, so this first one is going to be 7 times 5 minus 9 times 0. So we'll put the work here. So 7 times 5 minus negative 9 times 0. 7 times 5 is 35. 9 times 0 is 0. So 35 minus 0 is just 35. So we'll put that here, 35. We'll do this one next. This is negative 1 times 5 minus negative 9 times 2. So negative 1 times 5 is negative 5. 9 times 2 is 18. Negative times a negative makes it positive. So plus 18 is looking like positive 13 to me. So we'll put that one here. I don't need that much room. And then we have this one, negative 1 times 0. I guess I can do it a little bit faster now. Negative 1 times 0 is 0. Minus 14 is negative 14. And then we have this one, 0 times 5 minus 0 times 3 is just 0. 3 halves times 5 is 15 halves minus 6. Go ahead and write that one out. 3 halves times 5 minus 2 times 3, so minus 6. Oh, we'll go ahead and write it. So we have 3 halves, that is 15 halves. Minus 6, so that's going to be 12 halves. So that's going to be 3. 15 minus 12 is 3, and it's going to be positive 3 halves. So this one's going to be 3 halves. So essentially what we're building here is a matrix consisting of all of my determinants of my original matrix. So we have this one. This is 3 halves times 0 minus 2 times 0. So this is 0 again. We have 0 times negative 9 is 0. Minus 7 times 3 is 21. So it looks like negative 21. And then 3 halves times negative 9 minus negative 1 times 3. So 9 times 3 is 27. 27 halves. And then 1 times 3 is 3. Negative times a negative makes it positive. So it's a positive 3. So that is going to equal 27 halves plus, let's see, 3 times 2 is 6 halves. So 27 plus 6, looking like 33 halves. And then the last one, 3 halves times 7. So this is going to be 3 halves times 7 minus 0 times 1. 0 times a negative 1, rather, which is just 0. So 7 times 3 is 21 again. So we've got 21 halves. All right. So this is where I made my mistake that last Thursday. I haven't forgotten about it yet. So I just want to make sure that I do correctly. So right now I have to, I'm going to apply this cofactors rule. And maybe one day we'll practice it because it is a little formula that will throw you for a loop. But it's good practice. So we'll go ahead and just use the cofactor matrix here. And what it is, we'll do it small. It's plus, minus, plus, minus, plus, minus, and plus, minus, plus. So each one of these are going to get multiplied by an additional, like a coefficient of either positive 1 or negative 1, essentially. So we'll just rewrite this in terms of the cofactors. And my marker is really weak. It might be time to switch them out. So let's just rewrite these real quick. And then 35 is already positive. It's going to stay positive. 13 is positive, so it's going to become negative. 14 is still negative. 0 is neither positive or negative. 3 halves is going to stay positive. This one here is 0, so it's just going to be 0. Plus is going to stay minus. 33 halves is going to become negative. And positive 1 is still positive. It's going to be 21 halves. All right, so we have this now. And what we have to do now is we're going to transpose down the diagonal. So we've got to make one more adjustment to this matrix. So these numbers are going to stay the same. So we'll just write it right next to it here. Fit it in here. So we've got 35, 3 halves, and 21 halves. And then these two positions across the diagonal are just going to switch places. So we have negative 13, 0. And we've got negative 14, negative 21. And then we've got 0 and negative 33 halves. So this is transpose. And then the last step in calculating the inverse is multiplying. So we didn't write the formula anywhere. Where do I fit that formula in here? So we have this thing right here. So A inverse equals, so it's 1 over the determinant of A times, it's called the adjoint, ADJ of A. So that's what we're doing here is we're calculating the adjoint matrix. We've already got the determinant. So one more step in the adjoint, or no, this is the adjoint. So this is the adjoint. So all we have to do now to calculate this inverse is multiply this matrix by 1 over the determinant. So 1 over D is going to equal 1 over 21 over 2. So what we're going to do is we're going to invert and multiply. So it becomes 2 over 21. Because when you multiply, you get 1 over 1 times 2 over 21. If you're inverting and multiplying that second term. So that becomes 2 over 21 is what we're going to multiply by, 1 over the determinant. So we have 2 over 21. And as careful as I was, I ran out of room. So we'll just try to do it really quickly. I'm going to sneak a little bit and get a little bit more room in here. See if I can sneak 2 over 21 here. So I don't have to put it here. And then so we have 35 times 2 is 70. So we've got 70 over 21. 2 over 21 times 0 is going to stay 0. 2 times 21. That's just going to be 2. So we've got 2 times 21 is 42 divided by 21. It just gives us 2. So this is going to be negative 2. Two times 13 is 26. So that's negative 26 over 21. 2 over 21 times 3 halves. That's going to be, it's going to end up 3 over 21. 3 over 21. 2 over 21 times 33 halves is going to become negative 33 over 21. And then 2 times 14 is negative 28. I need a little bit more room. Negative 28 over 21. That one's going to stay 0. One more. We've got, oh, nice. So that is 2 times 21 over 21 times 2. So that's just going to equal 1. Anything divided by itself is equal to 1. So you end up with the same numerator, same denominator. All right. So per this formula, now all we're going to do is, well, this is my A inverse. So all I have to do is multiply it by this single matrix to figure out the solution. See if I have room to do it. 15, negative 45, and 22. And hopefully it works out. So what we're doing is we're just taking this row times this column, and this row times this column, and this row times this column. So the first one, we have 70 times 15 is going to give me 1,050. I'll have to get down. So we'll put it here, 1,050 over 21 times plus 0 times negative 45 is 0, plus negative 2 times 22. So that is minus 44. So we've got to get a common denominator. Actually, this divides. 2050 divided by 21 is 50. It goes in exactly 50 times. 50 minus 44, that equals 6. So our first value, x is 6. We verified that already. So now let's do this column. We've got negative 26 times 15. And I'm getting a negative 390. And that is over 21. We've got 3 halves times negative 45. So I'm getting, hold on, negative. I'm getting negative 135 over 21. And then we've got negative 33 halves, or 33 over 21 rather, times 22. 33 times 22. I'm getting 726. It's a positive. 2 negatives make a positive here. So that's going to be a plus 726 divided by 21. Since they all have the same denominator, we can just add and subtract these numbers. So what I like to do is I like to combine the negatives first, because when the signs are same, you add and keep the sign. And when the signs are different, you subtract and keep the sign of the larger number. Whatever number has a larger absolute value. So 390 plus 35 is 525. And it's negative. So minus. And it looks like I'm getting a positive 201. Ah, and it doesn't divide. So what did I do wrong? I made a mistake. Tragic. Hang on. Let me just multiply these rows again to make sure, because if I didn't, then I'm going to have to rework this whole thing. All right. 726 minus 135. 201. Yeah, I'm getting, this is not right. That equals 201 divided by 21. So I must have gotten a hurry and made a mistake somewhere, because I can tell that that's not the correct answer. Let's see if we got this last one though. See if we're on the right track. So we've got see, negative 28 times 15. That is 420. See if I can sneak it in here. Well, and it's Monday. I haven't done math all weekend, so it's one of the reasons why I want to do this is so that I have practice. So we've got, here, we'll scoot over just a little bit. I just want to do this last row. Negative 28 over 21 times 15. Is 420. So we have 420 divided by 21. And that does go in evenly. That equals 20. So we've got 20. And then 0 times negative 45 is 0. And then 1 times 22 is just 22. So what we have is negative. Hold on. So that would be negative 20 plus 22. Oh, okay, good. So we have negative 20 plus 22. That one works out. That one checks. So it looks like there may be an arithmetic error. So what I need to do is I need to go recalculate the determinants, because we were able to calculate X and Z, but for some reason 3 is not working out. And since I'm having to do math by myself, there is an arithmetic error in here somewhere for Y. So what I'll have to do, since I'm already 41 minutes in, I'm probably just going to stop there, find my mistake later, and come back and correct it tomorrow. That's really all I can do, because I'm really out of time. I feel like 40 minutes is entirely too long to work a problem. So I'm working on it. Anyway, if you watched my video and you liked it, I really appreciate it. If you have any math questions or anything that you would like to see me work, then I would be happy to give it a go. And in the meantime, I will just go ahead and sign off and say goodbye for now. And I hope everyone has an amazing rest of their Monday evening, and or whatever day it is that you end up watching it. And yeah, I will see you next time. So bye.